Try that and see what happens. We'll try multiple paths. So the y-axis is when x is what? So we're looking at the limit as 0y goes to 0, 0 of 0 over what? Well, it's 0 times sine squared, so it's going to be 2y squared, which is going to be 0. Looks pretty likely. Okay. And then you could do the limit as on the x-axis. So, sorry. You could do x0 goes to 0, 0. And you end up with what? 0 over 0. That doesn't tell you anything conclusively. Another one that you saw that you could try y equals mx. That's any line going through the origin on the xy plane, right? If you try that, does that help you at all? No, you keep on getting what? You keep on getting 0. So you think it's going to be 0. So you have this feeling that it's equal to 0. Is a feeling enough to prove it? No, a feeling is not enough to prove it, unfortunately. So what do you need to do? Squeeze theorem, yay! Okay, ready? Let's go. Let's have a little story time. Sine y has to be less than or equal to what? Greater than or equal to what? -1, right? Okay. What about if I square it? Careful. 0 to 1. Thank you. What would be a really common mistake right there? It's between 1 and 1. No, it just makes it positive, right? Great. What about this? Let's multiply it by x squared. Sound good? Less than or equal to what? X squared, right? Okay, so what's the limit as x goes to 0 of 0? Yay. What's the limit as x goes to 0 of, oh wait, hold on, am I getting this? I am, good. Of x squared, sorry, of x squared. 0. Therefore, by squeeze theorem, what do you know? The limit as x squared, sorry, the limit as x goes to 0 of x squared sine y is going to be 0. Do you agree with that? As x goes to 0. Did we specify any sort of path, any particular path? No, we did not specify a particular path. So therefore, this could represent general path to x being 0. And this is any path to x being 0. Does that make sense, everybody?
What about the
Hold on. Let's just pause this for a sec. You're treating y as a constant. Uh-oh. Yep, good. Good. It's recording. So if you treat y as a constant, what's the derivative of -2y squared?
Oh, yeah.
We're treating y as a constant because we're finding the rate of change with respect to what? X. Just x. So now we have this. So if we wanted to do, let's see if it comes out relative fx of 2, 1, what's it going to be? 3 times? Isn't that what it asked for? 2, 1? Right? fx 2, 1? 2 plus 2 times 2 times what? 1. So what's that going to be? Is 16. Now what about f of y, xy? What do you fix?
X.
You fix x. So what's it going to be? 0 plus 3x squared y squared minus what?
4y.
What about the what? 4y what? Nothing, right? So we're doing f of y at 2, 1. What do you get? 3 times minus 4 times 1 is 12 minus 4 is 8. 12 minus 4 is 8. Now here's the thing. This right here does not correspond to this function. That's just a picture to illustrate a general sense. Let's just take a look at this, see what it looks like, and see if we actually believe it. Let's see if we actually believe it.